Hi everyone, this presentation will focus on a practical retention discussion problem, predicting telecom consumer churn and how to improve the retention through data-driven decision. Churn is costly, but retention budget and outreaching capacity are limited, so resources must be prioritized for the customers most likely to churn. This presentation will include the business challenges and constraints, the dataset and method choice, result and key churn drivers, and an actionable top K targeting rule and retention recommendations. Here's a brief exclusive summary. In telecom, churn has created the major cost to the company, so the key is not only prediction, but turning prediction into action. A public telco churn dataset is used as a proxy for a CRM setting with 7,035 records after cleaning and a target of stay versus churned. Logistic regression is used as the main classification method to produce churn risk score and a prioritized list under budget and capacity limits. On the test set results, accuracy is about 80.2%, 56.7% on recall, 88.7% on specificity, and 64.4% on precision. Overall, the module is best used for ranking and top K targeting. The business goal is to reduce avoidable churn and protect recurring revenue. However, resources are constrained, incentive budget and outreach capacity is limited, and the data privacy must be respected. Therefore, the key decision is, in this billing cycle, which customers should be prioritized for retention. In this case, stakeholders includes the marketing and customer service team who need an actionable list and clear next step action. Finance manager which sets budget limits, and customer who care about experience and fairness. Constraints come from budget, capacity, and compliance. These constraints support a top K approach that focus effort on the highest risk customers. After cleaning, there are 7,035 customer records. The dataset includes demographic, service subscription, and billing features, with a target of stayed versus churned. The key assumptions are, the risk of churn will be assessed for the next billing cycle. A public dataset is used as a proxy because proprietary CRM data is not available, and results should be validated and turned on real CRM data before deployment. While churn is a yes or no outcome, so classification fits the most. Logistic regression is widely used and could give a stable outcome. It gives a churn probability for each customer, which supports risk ranking. Moreover, the coefficient is also easy to interpret, so key drivers can be explained in business terms as well. However, there is limitation, that it may miss complex nonlinear patterns or interactions. Therefore, it is used mainly as an interpretable model for ranking. The workflow has been split into 5 steps. First, the data is cleaned by converting total charge to a numeric format and handling missing values. Then, a pre-processing is applied. Median imputation for numeric files and most frequent imputation plus 1 hot encoding for category files. A train test of 80% for training and 20% split is then used, with random state equals 42 for reproducibility. Finally, a logistic regression model is trained and evaluated using a confusion matrix and key metrics such as accuracy, precision, recall, and specificity. As the outcome shows, the accuracy is about 0.8, so the overall performance is solid. The business relevant metrics represent that the specificity is around 0.88, meaning fewer offers will be wasted on customers who will stay away. Recall it's around 0.57, meaning some real churners will still be missed. And precision is around 0.64, which means that high-risk list is reasonably trustworthy. There are 3 key coefficients drive to churn. Month-to-month contract shows the highest risk, as the cost of switching plan is low for customers, so they are more likely to switch when there's a better alternative choices. Fiber service and higher charge are linked to higher risk as well. This often pointing to price sensitivity or higher per-service expectation to telecom. And electronic check payment also shows a higher risk, which can reflect on billing friction. The ROC curve shows an AUC of 0.835, suggesting the model can generally rank likely churners higher than non-churners. This outcome supports the use of the model for risk ranking. The summary metrics indicate that the false positives are relatively low, but some churners will still be missed. Therefore, instead of using one fixed cutoff, a practical rule is to rank customers by churn probability, and within budget and outreach capacity, telecom should target only the top K percentage customers for each billing cycle. The classification tree is included as a simple if-then snapshot to provide a quick sanity check of the key signals. To develop a budget-aware retention plan, the key idea is to focus on limited resources on the customer most likely to churn. The first recommendation is to apply a top K targeting rule for each billing cycle, rank the customers by churn probability, and contact only the highest risk group within capacity. Meanwhile, prioritize construct migration. Month-to-month customer shows a higher churn risk, so target upgrade offers can move them to longer construct and increase commitment. Moreover, reduce friction and increase stickinesses. For higher risk customer, especially those with higher charge for fiber service, improve the value story of the service and the service experience. Encourage customer adds-on like security or tech support to make the service harder to replace. This also includes reducing billing friction, for example, encouraging auto-pay or simplifying payment for electronic check customers. However, there is few risks are noted. Owing to the data its public proxy, results should be validated on real CRM data. If churn is imbalanced, cost weighting or resampling can be used. In conclusion, this interpretable churn model was built using logistic regression, and the result highlights a set of clear churn risk signals. Based on these signals, a practical retention plan was proposed, designed for budget and outreach constraints, using a top K targeting rule and focus actions such as construct migration and reducing frictions. In the real business setting, the approach should be validated and calibrate on actual CRM data and refine with more advanced models. That concludes my presentation. Thank you for listening.